Okay, for my classes, we have covered everything that we need to know for this quiz that's going to happen tomorrow. I'm just going to do a little quick review with you, and it's going to cover basically two things. It's functions, and it's either algebra of functions or it's the graphs of functions. And on a function, here's a typical one. F of x equals x squared minus 3. And let's say, no, let's say not use f, let's use g of x, typical other function, equals x cubed, let's say. All right, write those two down. Now from here, we can do a simple one like what is f of 3. Now in this scenario where I say f of 3, I'm either telling you an x value or an f of x value, which is the same as y. In this case, did I tell you what x is or did I tell you what y is? I told you x. I told you x is 3, right? So you use the right function, the f function, and I stick in, what? 3. So all I got to do is I'd rewrite this thing as empty space squared minus 3, and then I drop in whatever's here, whatever they told me to drop in, I drop it in there. And then 3 squared is 9, minus 3 is 6. Raise your hand if you had 6. Okay, good. Let's try a trickier one. F of p. Use the same process. You ask yourself, well, what's the f function? It's something squared minus 3. And then I got to put something in that empty spot. It can't be x because I told you what x was, and it's right here. So all it is p squared minus 3. You just drop the p in, and just like you drop in a number. Raise your hand if you had that one right. Okay, good. What if I say f of x is equal to 13? Well, in that scenario, obviously we're still dealing only with this one, so I would write it out. F of x equals x squared minus 3. Why didn't I leave an empty spot for x? Because they didn't tell me the x. What'd they tell me? If they told you the y, what's the same as y in this equation? The f of x. The f of x should be replaced with a 13. And then you just solve it from there. All right, so if I take 13 and then I do what? I add 3 to both sides, and I got 16 equals x squared. How many of you got fooled into thinking that it was 4? Or is it actually 4? All right. Oh! Say it again. Very good. Because negative 4 would also work. All right. I know it's kind of cheap, but it's going to happen. Some of you guys are going to make that mistake. Because when you take the square root, what really happens is the square root of x squared is not x. The square root of x squared is the absolute value of x, which is why you split it into 2 parts. In case you forgot how to do absolute values, it goes like this: x equals 4 or x equals negative 4. And the reason is, if you go back to the original problem, if I stick in a negative there, it will get squared away, like the negative doesn't even happen. So, all right, so there's actually 2 answers on that one. Okay. Moving back to the 2 functions, f of x and g of x. Let's see who's smart enough to handle this one. F of g of 2. All right, when a problem has got multiple layers, start on the inside. You work your way out like the alien inside the human. Okay, g of 2. If I want g of 2, I go over here and I figure out g of 2. G of x function is something cubed. Then I drop whatever they told me to in here, and I told me to drop in a 2. So g of 2 would be 2 cubed, which is 8. So I drop in 8. So now it's f of 8. See, I just replaced g of 2 with 8. Now it's f of 8. 8 squared is 64. I'm going to actually write this out so I don't screw it up. F of 8 is equal to empty space squared minus 3. Drop in an 8. 8 squared 64 minus 3 is 61. Raise your hand if you had the answer. Excellent. You guys seem to be tracking really well. So let's see if you can handle this one. What is g of f of x? G of f of x. Well, where do you start? Yeah, on the inside. What's on the inside? F of x. Do you know what f of x is? Yeah, it's right there. So it's really g of x squared minus 3. Now it's a new problem. Now I start with the g function. I go to the g function and say, what am I going to put in there? G of x is empty space cubed. And what do I drop in there? X squared minus 3 cubed. Now that is a tough one. X squared minus 3 cubed is not as simple as take x squared and cube it and take the 3 and cube it. That is wrong. It's this. How do you FOIL a triple? There is no snappy name like FOIL, except it's like, you know, Foigle or whatever. There's no name like that. But what you do is you FOIL this one. And once you're done with that, you'll have a triple. And that'll be x to the 4th minus 3x minus another 3x makes minus 6x squared plus 9. There, I did the first part. And now I got to do it times x squared minus 3. Do you remember me talking about the giant clam? Or maybe I haven't talked about that in this class yet. Have I mentioned the giant clam to you yet? Do you see the blue? Looks like a giant clam. All right. You take and you distribute out that x squared 1 to everything. And you distribute out this 3 1 to everything. And it looks kind of like a giant clam. Just in case you're ever... Would you please multiply that while I'm telling you a very short little story? In case you're ever swimming in the bottom of the ocean and you see a giant clam, it's very tempting to stick your hand in, touch it, because a lot of times they're open and they're like, you know, trying to like fan through, filter out seawater and get things they can eat and stuff. And if you touch in there, what happens? Snaps down shut. Which, it doesn't like snap your hand off or anything. But let's say that it's just a little uncomfortable, but you can't get your hand out. Can you see a problem with that, being that you're on the bottom of the ocean? Eventually, your tank is going to run out of oxygen, right? And when you want to get up to the surface, how will you do that? Dragging a 75-pound giant clam. If it comes uncemented off the floor of the ocean, which is going to be really, really hard to do. So there have been many people have died sticking their hand inside a giant clam. They don't die instantly, but they die because they can't get it off and they can't get back up to the top. And the thing, it's not as even like sharks are easier in a way, because you just bat them about the nose and they let go because they got a very sensitive nose. These things don't have anything really sensitive. So unless you can get out your giant you know, Bowie knife out of your belt or whatever, yeah, and like cut the thing open and get your hand out. I guess maybe you could gnaw it off and then get up to the surface. It's a little bit like that guy who had to cut his arm off with the boulder. I haven't seen the movie yet, but yeah, I can't even think about it, much less watch the movie about it. Oh, so uncomfortable. The clam? No, you're stuck there until you figure it out. Okay, if I actually was on the bottom of the ocean, I had a half a tank of oxygen, I'd be more thinking about getting somebody else to know that I'm stuck there so that they can get me their oxygen. You know what I mean? So that they can like bring me an extra tank of oxygen until I figure it out. That's what I'd be thinking about. If you have explosives with you, that might... Oh, I gotcha. Okay. I really don't know. I mean, if you're diving alone and that happened to you, I think you're in deep trouble. You're right. That's a yeah. If you had something that you could wedge in there that would, like the jaws of life thing, open it up. But I don't. Yeah, that's just, it's a good problem solving idea. If you could get something flat that it must be open enough to have your wrist, right? So it must be that far open. So if you could get something in there, besides your other hand, which you got, then you're even worse off. But it's something else in there that would expand like the oxygen, like the air thing. That's a great idea, actually. That could work. All right. Anyway. Got a little off topic, but that's okay. I want to talk about the graphs. So let's say this is 10, 20, 30. This is not terribly accurate. That's okay. Let's say that 1 is at 20, and 2 is down at 10, and 3 pops up to 30. And this is a function. First of all, is it a function? Yes, it passes the what test? Vertical line test. Okay. And as such, a function can be evaluated at any number, like f of, let's say, 2. Well, that means that I told you what, x or y? I told you x was 2. So then you'd read up to it and say, okay, well, it goes up to, it's supposed to be at 10, so the answer is 10. Simple as that. So if they give you a graph and they just say one of those, that's the easy kind. What happens if they say f of x is 20? Did I tell you x or y? I told you y, and so therefore I want to know what? X. What is x? Well, if y is 20, I go to the y's here, and y is 20, and I follow it over, and there's my spot. X must be 1. All right. But, yeah, I know this graph is not terribly accurate. I'm aware of that. Okay. So back to, let's say, instead of saying f of x is 20, this is the kind that gets a lot of people. F of x minus 4 equals 20. All right. So what do you do first? The first thing you should always ask yourself is, did they tell me x or did they tell me y? What did they tell you? They did not tell you x. They told you y. X is still there. See, it's an x. So they must have not told me x. They told me y. Y is 20. So here, I know y is 20. So start there. So you go here and you say, okay, if y is 20, I follow that. And the answer is like about 1. And what do I do now? Where do I put the 1? No, you don't put in a 1 right there. False. How about this? What is a true statement involving a 1 and a 20? They are both numbers. I'll get you started. What can I write here in the front of it? There you go, f of 1. Do you get how f of 1 is 20? See? F of 1 is 20. So if f of 1 is 20, then we really are saying that that is equal to 1, right? So now x minus 4 equals 1. Add 4 to both sides. X equals 5 is correct. You get what I just did there? All right. I know some of you didn't. That's okay. We're going to try to get you on this next round. All right. Instead of f of x is 20, I'm going to say f of 4x. No, let's make it 3x. F of 3x is equal to 30. Now, did I tell you x? No, because there's still an x in the problem. So what did I tell you? I told you y. If y is 30, then what do we know? come on, f of what is 30? F of 3 is 30. If these are both true statements, f of x is 30 and f of 3 is 30, then you get how that has to equal that? And therefore, what's x got to be? 1. I didn't say f of x is 30. I said f of 3 is 30. But in this problem, x equals 1. All right, last one on your own, and we'll see who can figure it out. F of 3x minus 2 is equal to 10. Did I tell you x, or did I tell you y? That's the first thing you should always ask. I told you y is 10. And just to clarify, y is 10 is supposed to be here, which is supposed to be there. Okay, so and now some of you are like, the answer's got to be 2 then. No, it's not 2. What's that true statement I could write under here? F of 2 is 10. And therefore, these have to be equal. Raise your hand if you've got the answer already. All right, that's only like half the class. From there, you should be able to handle it. Write out a little equation for yourself. Three x minus 2 equals 2. And then add 2 to both sides. 3x equals 0. And x must equal what? Oh, I just screwed up. Sorry. Okay, add 2 to both sides is 4. Sorry. And then 3x equals 4. And then x equals what? 4/3. So again, when you get to this kind, start by asking yourself, did they tell me x or y? They told you y. Then figure out a true statement that has the x in it, and then set these equal to each other. Okay? All right, that's the hardest kind of all. Now, one other quick thing to review here is increasing and increasing, increasing and decreasing, all that kind of stuff. Okay, so let's say that this is the speed, not the speed, the distance and the time on a car. Okay? At the beginning, were they going fast or slow? Slow, and at the end they were going? All right, so if I asked, let's say that we say this is A, and this is B, and this is C, and this is D, over which period of time was he going the fastest, you'd say, from C to D, all right? Because it's the steepest. All right, is this increasing or decreasing in general? Increasing at what kind of rate? Increasing. That's increasing at an increasing. All right? What's that? Increasing at a constant. Decreasing at an increasing, right? Because at the end it was going fast. All right? 2 parts. Increasing at an increasing, and then constant. And if that's going up, it would be a constant increase, but I was trying to make it just go straight across, which would be just constant. Okay, so if they ask, is this increasing or decreasing, it's a trick question. It's not increasing and it's not decreasing, it's constant. And can you be changing when you're constant? No, it's not doing anything. So if this is time and this is distance, what are you doing? Yeah, you are. No, this is not a speed thing. If I'm at that distance, let's say it's 10 miles, I'm parked at that 10 miles. Or there's one other smart kid answer to this. If this is the distance from home, and he's staying at 10 miles away, but if I told you he was moving, how is that possible? There you go. He's going in a perfect circle around the house. Because then he's staying exactly 10 miles from his house. Perfect circle. Okay? Yep. Yeah, now that would, yeah. Just to prove the math teacher wrong that the graph could be moving, the guy could be moving when this happens. But that's kind of weird. Okay. So now we have two things. We have a little worksheet to do in class, and I got to collect those scores you had in the homework. And we also have that little quiz to do off of the CENTIOs. Let's get the CENTIO quiz done first.